I said yes. Okay, this right here, this theorem talks about two chords intersecting in a circle. So that's what we have here. This is a chord, and it's especially called a diameter, but it's also a chord. We have a chord that intersects another chord, and this is our formula that we use when we have two chords intersect. Piece times piece equals piece times piece. So piece times piece equals piece times piece. Okay, so what that means is we take this piece times this piece equals this piece times this piece. So let's talk about this one's chord. What is this piece of the chord? 3. And I'm going to take that times this other piece. And what's this other piece? X. Okay. And then looking at the other one, I know that this whole thing is 12, and those tick marks mean that each of those are the same. So what are each of these pieces? So it would be 6 times 6. So piece times the other piece equals piece times the other piece. Okay, 3 times x, that's 3x. What's 6 times 6? 36, and that's easy. If you divide, you get 12. So this is the formula that you use when you have two chords intersect. Look at your next picture. Do I have two chords intersecting in this next picture? So it's going to be the same formula. As long as I have two chords intersecting inside of a circle, it's piece times piece equals piece times piece. So this is something else that you're going to want to get on your note card. Okay, so let's look at this chord here. What are the pieces of this chord?
X plus 3 and 4.
X plus 3 and 4. And then let's look at the other chord. What are the pieces of that chord?
X minus 1 and 6.
X minus 1 and 6. Okay, now all I need to do is distribute and start working it out. Okay, on the left side, what do you get when you distribute the 4?
4x plus 12.
4x plus 12. And on the right side, when you distribute the 6? 6x minus 6. Okay, and then from here it's pretty easy. What do you want me to do?
Minus 4.
Okay, so I'm going to subtract the 4x from both sides. When I subtract the 4x, the 12 drops, the equals drops. How much is 6x minus 4x? 2x, and then the minus 6 drops. You're going to add 6, which would make 18, and when you divide, you get 9. Okay, so that's the first theorem of the day. When two chords intersect, then we have the formula piece times piece equals piece times piece. Okay, this next one is about secant statements. So secant segments are segments that go, they're a line or a segment that contains a chord. So this is a segment that contains chord EC. This is a segment that contains chord AN. So that's what secants are. So we have a special formula for this. If we have two secants, this is a secant because it contains chord OG. This is a secant because it contains ES. If two secants are drawn out to an exterior point, then we have a new formula. Whole times outside equals whole times outside. Whole times outside equals whole times outside. Now, just real quick, on Friday we learned something. On Friday we learned something where these two pieces equal, but do you remember what the segments have to be in order for these two to equal?
Tangent.
They have to both be tangents. Good, Andrew. For these two to equal, these would both have to be tangent segments. And they're not tangent segments, they're secants. So when a secant and another secant meet out at an exterior point, then the whole piece of it times the outside equals the whole piece of it times the outside. So let's do this guy first. What's the whole thing?
18 plus 8. 26.
26. And then times the outside of it. And what's the outside of it?
8.
8. Okay, when I do the other one, what's the whole thing? Not 6x. 6 plus x, or x plus 6. That's the whole outside, x plus 6. I'm sorry, that's the whole thing. And then what's the outside? 6. Uh-huh. Didn't it say 940?
Yes.
Okay. Can you wait till 940?
It's like 9:39.
Oh, that clock's wrong. It's like 9:36. What's 26 times 8? 208. Okay, on this one I need to distribute. What do you get if you distribute the 6? 6x plus 36, or you could have written 36 plus 6x. It doesn't really matter.
Okay.
What do you do now?
Subtract 36.
If you subtract the 36, you would get
172.
172, and when you divide?
28.6.
28.666.
Okay, so let's say about 28.7 then.
You can't say that word. It's not a word. It's not a place.
Oh. What a bug.
Okay, let's flip the page real quick and find another one that's like that. Okay, flipping the page to page 24, the bottom example, example 15. Okay, example 15. Do I have a secant and a secant meeting out at an exterior point? A secant and a secant meeting out at the same exterior point? Yes. So we're going to use whole times outside equals whole times outside. Okay, I'm going to start with the easy secant first. What is the whole length of this one right here?
Which one? Oh, that one?
This one that I just... 13. Times the outside part of it? 4. Okay, now let's do the other one. What is this whole piece of OL?
3x.
Not 3x. 3 plus x, or x plus 3, whichever way you like to write it, I don't care, times the outside part, which is 3. Okay, do you all know how to solve that from there?
Yeah.
Okay, I'm just going to write etc. Let's go back to page 23 and learn the last theorem. Okay, the last theorem is about a tangent and a secant. A tangent and a secant. So this guy right here, which one is that? A tangent or a secant?
Tangent.
That's a tangent, and this one down here is a secant. So if we have a tangent and a secant meeting, this is our formula. Tangent squared equals whole times outside. So these would be things that you'd probably want to get on your note card. So if we have a tangent and a secant meeting, we have the formula tangent squared equals whole times outside. Okay, let's start with the tangent. What's the length of this piece right here? 10. So it will be 10 squared equals, now let's go to the secant. What's the whole length of the secant?
That's 6x, or 6 plus x.
6 plus x, or x plus 6, either one. And the outside piece of it? 6. Okay, how much is 10 squared?
100.
100. What do you get when you distribute the 6?
6x plus 36.
6x plus 36, or
36.
Subtract the 36, which makes?
And then you get 64.
And then if you divide?
64 divided by 6 equals 10.666.
Okay, so about 10.7? Okay, so this is the formula that we have when we have a tangent and a secant meeting together. I'll text you the assignment. Okay, so let me show you one more of this. Looking at example 13. Do you agree that I have a tangent and a secant meeting?
Yes.
So we're going to use the new formula. Tangent squared equals whole times outside. Okay, what's the length of the tangent? The length of the tangent is 12, so it's 12 squared. Okay, the secant, what's the whole piece? 16. And what's the outside piece? X. What's 12 squared?
That's 144.
What's 16 times x?
16x.
And simply divide and you get 9. Done and done. Okay, so I'm just going to have you try a few of each.
Okay.
Okay, let's try 1 and 3. This is on page 25. So let's try 1 and 3. And then let's try number 7. Let's flip the page. So 1, 3, 7 there. Are you guys hearing me back there?
Yes.
No, there.
I can multitask.
Okay, thanks. Number 9. Let's do 11. And let's do 14. So 9, 11, 14. 9, 11, 14. Let's see here. So we have secant, tangent, secant, secant. Let's call it good.
I'll miss.
137, 9, 11, 14.
I have Fonzie 12 number of this. So, we're going to put in this.
Yeah.
Okay, thank you. Now I'm on my
Yeah, mine was